Hello S3, in this video we are going to be looking at the computer processor. We already know the computer processor is the brains of the computer, and everything that a computer does goes through the processor. So this week we're looking at a bit more depth at what that actually means. So by the end of this wee lesson, you will be able to describe the purpose of the processor, and you'll also be able to describe the factors that influence the performance of a processor and therefore the wider computer system. So this here is what is known as the von Neumann architecture, and this is the architecture of the most modern computers use. So we've got the processor in the middle, where it processes information. That processor takes an input, probably from a user. It then outputs that information in some way, and in order for the processor to do its job, it needs to use main memory, which we know is RAM, and then backing storage, which we'll look at in future weeks. So the CPU is responsible for processing data in the computer. We know from last week that the process a processor goes through is called fetch, decode, execute. So it fetches instructions from main memory or RAM, it decodes them, figures out what that instruction means, and then goes and executes that instruction. Okay, and the processor can only do one thing at a time. It can only process one instruction at a time. If we drill that down and have a look at the different parts of a processor, this here's a diagram of what the inside of a computer processor might look like, and we're going to look at particular at the control unit, the ALU, and the registers. So the CPU contains a control unit, and the control unit coordinates everything that happens in the processor. So it's responsible for the fetching and the decoding of the instructions, and it also manages how and when these instructions are executed. So a processor fetches an instruction from RAM. Whilst it's in the processor, it needs to be stored somewhere. Okay, and that's what we call a register. So a register is a very small amount of storage in it. So most modern processors work at 64 bits. That's the amount of storage that is on the register. We also have the arithmetic logic unit, or the ALU, and its name is kind of self-explanatory. It is responsible for any arithmetic operations, so any maths, adding two numbers together, division, multiplication, etc., etc., or any logical decisions. So comparing two numbers and deciding which one of the two numbers is smaller, for example, would be a logical operation. Attached, if we look at the side here, attached also to the processor could be something called cache. So cache is similar to RAM, but it is faster than RAM, and because it is faster, it is more expensive to produce. So therefore, a processor might not have as much cache as it does have RAM. And because cache is located closer to the central processor or the processor than RAM, that means it's faster. And this diagram here kind of shows the speed between the processor and the different levels of cache. And then we have main memory, and then we have a backing storage. So the CPU to cache is really fast, the CPU to RAM is fast, and the CPU to backing storage is a little bit slower. So that's the inside of a processor, the four main parts: arithmetic logic unit, control unit, registers, and cache. If we look at a processor and think about the fact that a processor can only manage one instruction at a time, that limits what a computer can do. Nowadays, with modern advances in technologies, very rarely do you find a single core processor. Most modern day processors are multi-core. Okay? And multi-core means that it can do more than one thing at once. So if you take this illustration here of a motorway, the one on the left-hand side is a single-track motorway, so therefore the red car goes, then the blue, then the red car, the yellow, the blue, then the purple. Okay. If we look at the right one, which could be a quad core, so there's four cores in this example, each of these instructions or these cars gets their own pathway. so the processor can manage with them all at the same time. So nowadays you get a, well, example here, quad core, so 4-core processors, dual core, so 2-core, or we're even up to hexacore, which is where each processor has 8 cores, so it can do 8 things at once. The processor has what we call a clock speed, and the clock speed is how fast it can carry out the fetch, execute, decode cycle. Okay, and this is measured per second. It's measured as a frequency, so it's measured in hertz. Most modern processors are measured in gigahertz, but quite older ones would be measured in megahertz. So, for example, if we look at here, we have got a 1 gigahertz, 2 gigahertz, and 3 gigahertz. Because the 3 gigahertz processor is going through the fetch, decode, execute cycle faster, it's able to deal with more instructions per second. So if we take, for example, there a 2 gigahertz processor, it can manage 2 billion cycles per second. So that's 2 billion fetch, decode, execute cycles per second. So that's 2 billion instructions it can deal with any second. Here we have an example of a Dell laptop, and this Dell laptop has got an Intel Core i5 processor. It is quad core, and that means that it has got speeds from 1 gigahertz to 3 gigahertz. So if we take the number, the gigahertz, and times it by the processors, the number of cores, we get how many operations it can do per second. So this Dell laptop can do between 4 billion operations per second and 14.4 billion operations per second. The task for this week is similar in style to the one that you had to complete last week. There is a Word document attached to the assignment with a series of questions that you need to answer all about the processor. Okay, the answer to the majority of these questions will be in the slide deck that I have just gone through, so you might want to watch back this video or have a look at the attached PDF version. And we also have a notes document as well that you might find useful. Okay, as you're working through the assignment, if you've got any questions, queries, or problems, please either email us or if you post in the help and support channel in Microsoft Teams.